Okay, so this is actually the first question of section 2.6. I think it's a good place to start because it does an example of each type of regression we're going to be doing in this class. So you'll kind of get an idea of the different things you're going to have to do. So here's our data. It says the table below shows the number of individuals infected with the disease T days after it's first detected by the CDC. So the top row is the number of days since it's been detected, and the bottom is the infected individuals. Very fitting example, I guess. It says for each of the following problems, enter the regression equation values at least 3 decimal places. Enter predictions to the nearest whole individual. So the first thing it wants us to do is find the exponential regression. Okay. So for each of these, whenever you're looking for a regression, you're going to start by putting your data into the stat menu. So we're going to go to stat. We're going to edit our list. If we have something in here, like let's just say I have a bunch of numbers in there, I want to clear them out. I'm going to go up to L1. I'm going to hit clear and enter. So the left list, L1 is going to be the days. So I'll just put 1 through 8 there. Nothing skipped. And then I'm going to put the affected individuals in here. I'm just going to pause it real quick so I don't waste your time. Okay, so we have the data in there. The number of cases is in L2. So the first thing I'm going to do is find the exponential regression. So once the data is in there, I'm going to hit stat again. And I'm going to calculate something. So we go over to the calculate menu. We have 3 choices here for this course. We can either find the linear regression, which is option 4, disregard option 8. 4 and 8 are kind of the same thing, just the order they write them is different. So just stick with number 4. So we have linear regression 4. We have the quadratic regression number 5, which we'll use later in this problem. And if you scroll down, we have the exponential regression, which is the 10th option down. So that's the first one we're going to do. So we have our x values are coming from L1, our y values are coming from L2. We're just going to calculate. We're going to copy this down using 3 decimal places. So it says write the equation y equals a times b to the t. You see that's what this is. Y equals a times b to the x, but x can be the same thing as t. It doesn't matter. So our a value here is 764, 648. $764.648, and our b value is 1.063. Okay, so if you write our equation out, it would look like this. Y equals 764.648 times 1.063 to the t, like that. Okay, so it's used to model predict the number of individuals infected with the disease after 15 days. So we're just going to let t be 15. So we'll plug in 15 for that. So I'm going to do 1.063 to the power of 15, follow my order of operations, times the coefficient in front, 764.648. So I get 1,911.879. This is rounded to the nearest whole individual. So it looks like it'd be 1912. Okay. Now we're going to repeat the process. It's just we're going to find a different equation. Here was exponential. So now for part 2, we're going to find the linear equation. It's going to look like this. Y equals mt plus b. So my data is already in the stat list. So I don't have to add anything there. I'm just going to go back to stat and hit calculate. I'm going to use the linear regression, number 4. I'm going to scroll through all that and calculate again, and then just copy down the values for here. They have M and B. You'll see it's the same thing. We have A and B here. So this is going to be 62.155. And then my B value is 736.429. Okay, so my equation is going to look like this. Y equals 62.155 times t plus 736.429. Okay. Now it says, I think the next question is, I think I cut off part of it. It says, use the model to predict the individuals infected after 15 days. So the same thing as the first part. So after 15 days, I'm just going to plug in 15 for t. So I'll do 62.155 times 15. Oops. Insert 2 there. Plus 736.429. So my answer there is going to be 1,668.75 or 1,669. Okay. A little lower than the exponential regression. So then the last one is really the chapter 2 stuff, is the quadratic regression. Again, same thing. That is already in there. So I'm going to calculate, and now I'm going to use the quadratic regression, which is option 5. That, all the way through. And then I'm going to copy my values down. A is 3.649. B is 29.315. And C is 791.161. Okay, so then our equation will be, if I write it out, it's going to be a little ugly, but it's going to be y equals 3.649 times t squared plus 29.315 times t plus 791.161. Okay, so I'm just going to, again, find the number of individuals affected after 15 days, plug in 15 for each. So I'm going to start here, 15 squared times 3.64649. I'm going to leave that there for right now. Then I'll do 29.315 times 15. I'm going to add these together. This plus that plus 791.161. So I get 2,051.9 or 2,052. Okay, so that's really how you use the equation. Now it says which model best fits the data. So really, our data can look one of 3 ways. So I'm just going to draw 3 quick graphs here. 1, 2, 3. So when to use which regression? Well, if something's linear, the data is either going to go like this, in a general linear pattern, or it could go down. It doesn't really matter which direction it goes, as long as it's kind of in a straight line, something like that. That would be plot linear. If I have exponential, the data is either going to go increasing like this, or it could be decreasing like this on a curved style like that. That'll be exponential. And then quadratic, it's going to follow a parabolic shape. It could look like this, roughly, or it could look like this, roughly. Okay, so what I'm going to do is use the calculator to figure out what the data is going to look like. So the data is already in my stat menu. Okay, so what I'm going to do is I'm going to plot the data. I'm going to plot the stats, really. So I'm going to hit second stat plot. Now when I turn on the first plot, since plot 1 is off, I'm going to turn it on. So hit enter, I'm on. I want the scatter plot, and my x values are L1, my y values are L2. And I'm just going to hit enter all the way through. And then I'm going to hit zoom. And I want to be able to see the statistics. I want to be able to see the data. So I'm going to hit zoom stat, zoom now. You'll see it's kind of linear. So you'll see it's kind of linear. I mean, it has a slight curve to it, but honestly, I don't really agree with this. If we're basing it off the graph, I don't really agree with the answer they said is correct with quadratic. This particular example, I think, just based off the data alone, it would look like linear would be the best option. Okay, so I have to double check why they put quadratic, but based off this graph, the data looks pretty linear to me. So there's ways you can test it, but we're not really going to talk about those methods in this course. So for this course, we kind of just use the graph to judge, and based off this graph, I would say it would be mostly linear. but I'll have to figure out why.